Hi everyone, I'm Jiska, and this is my presentation about a Bluetooth user interface issue affecting all major operating systems, which makes ongoing machine-in-the-middle attacks very stealthy. Alright, let's take a closer look at this happy mitten box contents. Secure Bluetooth pairing modes, called passkey entry and numeric comparison, require the user to enter or compare a number. This prevents active machine-in-the-middle attacks. Think of this like a TLS handshake. However, Bluetooth works offline and without any trusted certificate list, so user interaction is required to guarantee a root of trust. Recently, multiple MITM attacks on secure Bluetooth pairing modes were published. This demonstrates that Bluetooth security is flawed. Yet, many devices do not even use secure pairing modes. Most headsets and IoT devices do not have a display or keyboard to compare or enter a number. In this case, the so-called just works mode, which skips the steps and enables active machine-in-the-middle attacks by default. However, this is only possible during the initial pairing, which enables keys, meaning that Bluetooth users trust on first use. So here you can see a pairing with two keys, and in a setup with the just works mode. And well, here you can see that if one exploits this, then you would get separate keys. So the machine-in-the-middle attacker actually replaces messages towards both ends in the pairing process, and this is not noticeable by the device under attack. And there was a lot of hype around secured pairing modes, but I never cared a lot because, well, the just works mode is just there, and then for many devices attacks are possible anyway. And then second, an attacker must not only break the initial pairing, but they must also be present in future connections. And if you look into a mobile setup, this is very challenging because the device under attack is moving, and if the attacker just fails once, messages and keys become inconsistent, and this could be detected by the device under attack. So the expectation is that if we know that we have a possible machine-in-the-middle attack in a browser, for example, then we would see a warning like this. So if something goes wrong with certificates, or in our case, trusted keys in a Bluetooth pairing, the user should see a warning. But the Bluetooth specification really overcomplicates security warning options. So in most cases, so the blue cases here, the user is required to see a notification of a security failure, but there are also various other options where it's kind of optional to warn the user or start a new pairing, depending on the key type, if it was bonded or authenticated and so on. So it's really confusing what to do here. So the first requirement to even warn the user at all would be that the Bluetooth chips on both ends of a connection realize that there was an authentication failure. And then they should inform the operating system and ask the user, like iOS or Android. So the Bluetooth specification is a bit misleading here. There's this HCI layer between the chip and the operating system, for example, Android, but it's optional. So in an IoT device, it would just be one chip without this HCI part. And this is something that they do for having lightweight IoT implementations. And for such implementations, LMP would not send any HCI message, but directly send an LMP disconnect to another chip with the error code of an authentication failure. But as soon as you have HCI, the chip is then informing the operating system on top instead. And then the operating system must somehow inform the user and is involved into this process. And this can introduce further errors. So on the way back, in the case of Android, the connection is still terminated, but Android just says, yeah, this is user terminated. And then the error code that the connection is just ended because of the user interaction is also forwarded to the remote chip. So the remote chip in some scenarios with Android just thinks, oh yeah, it was just a regularly terminated connection and not a security failure. But in most cases, initiator and responder would see an authentication failure, and then ideally the operating system would warn the user with some easy to understand pop-out, as the one that I just have shown before. So then there's something unexpected. So none of the devices that we tested would warn the user in such a way. And even worse, Google Android would just delete the pairing without displaying any message. So this is even the case for permanent pairings with numeric comparison, so pairings that were bonded and authenticated, and that allows reinstalling keys for a machine-in-the-middle attacker under certain scenarios, or it makes it easier to trick the user into reinstalling keys. And then all the other devices would not show a warning, and once the attacker is successfully using the old key before, etc., they would just continue with this wrong key or with the key that in between was not working without showing any warning, etc. So this was not what I expected. And here's the overall list, and you can see that the issue is independent from the Bluetooth version, so it's just there in all operating systems because it's in the user interface. And except from Google Android, an authentication failure looks just exactly the same as a regular connection failure. In this video, you can see an iPhone Bluetooth packet log on the left-hand side. The left smartphone is an iPhone 8, the right smartphone is a Google Pixel 5. And in the iPhone, we install a script that creates a controlled authentication failure similar to a machine-in-the-middle attacker. To do so, the script temporarily changes the connection's link key, and the output of the script is shown in the bottom. Once the Pixel user clicks on the paired iPhone to initiate a connection, the iPhone immediately disappears from the paired device list without a warning, and this is very confusing and makes it easier for attackers to trick users into reinitiating an insecure pairing in their presence. The iPhone's packet log contains an authentication failure because the key was changed on this end. So note that depending on who initiated the connection and where the key is changed, one would also see the case where you just see a remote user terminated connection instead of the authentication failure. And here in this video, you can see two iPhones. Upon an authentication failure, the device will only show that the connection was unsuccessful, which is the same error message as if the other iPhone was turned off or out of range. Once the iPhone switches back to the old key, the connection works again. As you can see, an ongoing machine-in-the-middle attack really looks just the same as a connection failure to the user. This machine-in-the-middle issue is anchored in the user interface, which should be hardened. It is not yet another Bluetooth machine-in-the-middle attack. So Apple and Google classified this as a security enhancement and will address it in a future release. But keep in mind that machine-in-the-middle attacks are always possible in the just works mode. And then surprisingly, Microsoft just closed the ticket and claimed that users had no way to interact upon a Bluetooth security warning, and because of this, they will not add any warning dialogues. Then I did not follow the intended process for opening a security issue in GNOME apparently, and because of this is, it has been a bit messy, but they are currently looking into this and will also address the issue very soon. The process with Xiaomi had been really weird, so they had additional questions, but the questions did not really address what I explained to them, even though I explained it multiple times, and then at some point the issue was just closed because of inactivity. And also interesting is that I mailed Bose twice, but I didn't get any automated response to my mails and also no other response from anyone, so I'm not sure if that mail address is working, despite it's even listed as a security contact, including a PGP key. You can very easily try to change keys on your own. On Linux, you can just change the configuration file, and on iOS and Android, I created more generic scripts which can replace contents of HCI messages during runtime. These scripts might also be helpful if you want to test anything else within the Bluetooth stack here. There will also be an internal Blue tutorial later during this WiseSec. So in case you want more details or have questions about internal Blue setups, you can go there.